Okay, so we'll be doing the lab today. This is one of the more complicated labs, I would say, as far as the wiring and stuff goes. So we'll work through it. I think our TAs are gonna be here, but a little late. There's STEM Fest going on, is a big career fair over at UMD today. It ends around 2. So I think they're both over there and will be coming here after they find that magic internship over there. You have an opportunity to do something fun though today after class. Federated Insurance will be on campus today. They'll be just down the hall in 2611 at 4 o'clock. So basically when this class gets over. So I encourage you if you can to go there. I was talking to another student here. They don't hire international students, but if as an international student, you're still welcome to go there and learn about their internships, especially as a new student. It's good to kind of learn about different types of positions. They have 2 different kinds of positions, what's called an analyst or a system analyst or designer, more of a IT position and a developer position. And sometimes interesting to hear how they talk about those 2 different positions and that sort of stuff. And they're always welcome to share. They have a career fair coming up in April that we can consider going down to. It's right in the week after another trip we'll be making down to the Twin Cities. So we'll see how that goes. But it would be really nice if you could go down. We'd like to try to support our companies. We're not a big school, so we don't have that many companies coming to visit and hire our students. So those who do, we'd like to support them, show up, eat their food, and smile and take their free stuff. It's a sacrifice you have to pay, but as a student, you sometimes have to eat free food and get free stuff there. So just be aware of that. So, okay, so that's 4 o'clock today, right after class. Just down the hall. All right, let's get started on the lab today. So going to unit 5, going on the lab and bringing up the lab directions. Here, oops, this is lab 8. Let's not do lab 8. Let's do lab 5. So again, you should do this. I'm not going to pair you up. I think we're going to work individually for this lab. So I'm going to clear that part out here because we used to have to pair up because we all, back in the pandemic, back in the olden days, we couldn't get Raspberry Pis for everyone, so we had to pair up. But now we can do this. So you want to make a copy of this lab, of course. And we'll work through the copy. So we're going to first kind of remind ourselves about binary numbers and display those with the lights that turn on and off. So we want to set up kind of 3 copies of the circuit we've done before. There's our wonderful TA. Oh, you stopped for food. I was saying that you were busy at the STEM Fest and you were trying to get an internship, but no, you were getting food. Oh. Okay. You have to keep up your energy one way or the other, right? How was the STEM Fest? What companies do you talk to? Wow. Sappy? Banner. Okay. Yeah. But was Bar there? Were they hiring any computer people? Because when I was first a teacher here, I worked as a summer as a computer person because again I needed money in the summer. As a poor teacher, I had no money and I had young kids. I had family to serve, so I would work all summer too with them. And so for a couple of summers, I worked with Bar and Peter, and that was really cool. So. Right. Yeah. Okay. Okay. Yeah. Get connected to the little help line. Right. Okay. So get your circuits going. We're going to want to create these circuits here. Basically, we want to use control 3 pins going to 3 different circuits And each circuit should have an LED and a resistor going to ground here. So that's our whole idea, is to have 3 pins here, wires going from the first 3 pins kind of on this, and then going to an LED, the LED going to a resistor, the resistor going to ground for that here. So this is our wire. So while we work towards that, I'll start turning this down here. So let's see. And let's stop sharing. So again, here's one. I mean, I'm going from the pin over here to one of our rows, running the LED in that same row. And again, with the longer pin going to this positive cable, the shorter pin going that way, and then running a resistor back to ground. And we want to do this 3 times. So you want 3 versions of it. So you have 3 different LEDs. If you need more LEDs, talk to me. We have some more up here. Again, once you start getting your wires there, kind of verify your circuits, make sure that the metal parts don't touch each other or just, accidentally. And then you want to go into bring up your Raspberry Pi. We're going to do some Python programming. So remember, we go into the under Raspberry Pi programming. We want this Thani Python programmer. So we're going to bring that up. Now the code for this is in your lab. You can highlight that and copy it. Go in here, we're going to do a new file, and I'm just going to paste in that code. I'm going to go copy the code again, apparently, and paste it in again. See if that'll work. Let's copy this code, paste it in here. Oh, I know the problem. Yeah, so yep, so I had to paste it in here. I'll have to do something. I have to bring it up on my Raspberry Pi because I'm actually on 2 different computers here. So I'm going to bring up the lab in my Raspberry Pi also so I can view it there. So if you get this working, it should kind of count in binary. So here's my code that's running here. And I run this code, it should be going 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5. And so I should see my lights blinking. So 1 is counting 1, 2. Right now I'm only getting 2 of the LEDs coming on. So this one's coming on for a while. And the green, my middle one, which is green, doesn't seem to be on. So I'm going to check that. But again, I'm going to stop this and verify that circuit and stuff. So you should see this counting off in binary format. Well, where it'll be 1 on, 1 off. So again, maybe we'll just write down the screen what that'll be. But you should see all 3 of them blinking as we go. So again, with your lights blinking, it should be counting up in binary. So it'll go 0, 0, 0. The first time's all 0, then 0, 0, and 1 will be 1. And then again, when we count in binary, we go 2 is like this, 3 is like this. And again, we'll add 1 to this. We'll carry it on. So 4, this is 4. And then now 4 will, and then we'll start again. This is 0, or this is 5, 4 plus 1, 4 plus, 4 plus 2, 4 plus 3. And then we go back up. So you should see it kind of going in this sequence when you run it. So if we run this and look down, the red in this case is the first digit. So that's this is 4, 5, 6, 7, and then 0, 1, 2, 3, 4, 5, 6, 7 was all on, and then back to 0 where they're all off. So see if you can have your circuit set up here so it's counting in binary as we go. Okay. And again, if you want to stop this, you hit Control C inside this little window over here, oops, with the right keyboard, and that'll shut everything off and stop this. So again, I'm not going to go over this Python too much. We wire up our circuits, our LEDs to different pins, and the first 3 pins are actually numbered 16, 20, and 21. You kind of think they would be all in order, but they're not. I don't know why not. But if you look at the numbers, at least on mine, they are numbered that way. So 16, 20, 21 there, and our counter, our C counter is set to 0 there. And then we enter a loop, and the loop loops forever. So we say while true, so it'll always loop. We turn all the LEDs off, and then we add 1 to our counter, and we do this mod 8, which means remainder. So it'll divide by 8 and give us a remainder. So the remainder, when you divide by 8, is always a number between 0 and 7. If it were 8, it would be divisible by 8, and you'd get another 1. So the remainder is always between 0 and 7. We print out that number, that count, and then we do some really weird math stuff with something called binary shift, where we shift things over to get the bits, and that'll let us quickly figure out which of the LEDs to turn on and off. And we sleep for a second. And then, now, if you wanted to sleep for a little longer, you could actually change the sleep time to like 5. And then when we run this, it will blink a much more slowly. Let me see, where's my, get this one. So now it'll keep, this is 3. Now it'll go to 4. And now it'll go to 5. So it's going slowly now because I changed this sleep timer. Okay. Okay, so remember, set that up. What do you need to submit here? So we want you to write a little bit about this code. What does this line do? And then describe what these lines do and submit that here. And take a photo of your circuit and describe what the 2 segments above do for this. You can have AI help you understand this code because, again, this isn't a Python coding class. Particularly this, I think even our advanced programmers have not seen bitwise shift operators other than in this class. Have you ever done bitwise shifting in anything else? No, you never have to do this, but we're using it in this class. So yeah, you can use AI to help with these descriptions, but make sure you get a picture of your circuit, and then we'll go on to our half adder, which will be 2 LEDs, similar to how we have. So you'll just remove one of the LEDs, keep the other 2 there, and then we have to add 2 buttons here to get that to work. So it only looks like that. Not hard at all. So you can do that. Okay, so call us over if you're having trouble with the LED counters. If you get done with that, make sure you get a good picture of it before you go on to the half adder circuit. So it's count 0.
Because I don't know how to download the Is that you already said? Can you remember if it's,
Deleted the user.
Deleted the phone number, not the user.
You just go home.
You should have gone with me now when she was this. I actually don't know that all this. Yeah.
So again, for part B, once you get your circuit done, if you push down either button, oops, I have to run this. And I run the right program. Okay. I should push this down and see now. You can also look at the output to see if the buttons are being read. This shows that B is on because I'm pushing that button, and it should show that S is on with one of my LEDs. And if I push the other button, it'll show that that other button A is on and S is on, but carry the C is off. Now, if I hold them both on, you can see them on. So one thing to watch is if your buttons are working, you'll see them showing up as the zeros and ones. But if your LEDs are not working, then it means that the problems with LEDs. If this display isn't changing, it means your buttons are wrong. So you can kind of determine if I'm pushing buttons and the display here is not changing, then that means it's the LEDs. Oops, I should have been sharing this. So again, this is this display here. I can't really share both of these, unfortunately. So again, if I'm pushing the button and button, it'll show on the display. So once you've programmed these in, you might want to save them. Again, if you click on one of these tabs, you can hit save and give it some name. So like this was my first part. So like lab 5A, if you want to call it something like that. Now, these files should have a .py extension for Python. It'll add it automatically if you don't here. Also now for the last part, it asks you about some Python code. You can grab this Python code and just paste it in here. And grab it, go back to your editor, create a new file and paste it in here and run. Now, I'm already running the old program, so I have to actually go here and quit Control-C the old program before I can run this new program, and it'll print out the results. And your job is then to figure out why it's printing out, why it's calculating or displaying some of these things. So, okay. Again, make sure you take a picture of your circuits for A and B. You have to submit those here. And then again, the rest is code stuff that you have to describe some of this code and how this works. Remember, the write-up is due by Sunday night. So if you don't get everything done tonight, that's fine. You just make sure you get your pictures taken today before you leave and you have everything working there. All right.